So basically now, in order to be able to seed our scaffold, which will be our 3D printed larynx, we need to be able to trypsinize cells. Basically, we've been growing these cells now for probably a week or so, and the cells have now reached confluency. And confluency means that the cells have occupied all the space in this flask. And if we don't trypsinize the cells, in other words, lift them, these cells will eventually die, because when the cells are too crowded, they start to produce toxins and they kill each other off. And also, we need these cells. We need to be able to detach these cells because they are adherent cells. They're stuck to the flask. We need to be able to detach these cells and then spin them down to create a pellet, and then reconstitute that pellet to be able to add these cells to our scaffold, so that our scaffold has got these living cells on it. So now Hassan is going to trypsinize these cells. So the procedure is that we remove the culture medium that they've been growing in, and then add a special medium, which is trypsin. Trypsin is an enzyme that allows the sticky proteins that keep the cells stuck down to detach. So break the bond between the cells and the surface of the culture flask. So you'll see that everything is done within the confines of the sterile cabinet, because obviously the conditions have to be kept completely sterile. So the media that they've been growing in is now being removed, and this will be replaced with the medium that will allow the cells to detach. Are you going to do a PBS wash first?
Yeah.
So first we'll do a wash with a special solution to remove any remaining culture medium. And then we'll add the trypsin solution that will detach the cells. So a known volume is added to the culture flask, and this is given a little mix, a little shake, to ensure that any remaining media is removed. So it's basically a way of washing the cell layer. And of course you will have noticed that with every procedure you change your pipette, you change the instruments that you're using, and this is to prevent any contamination of the cells. Yep. These solutions are usually all pre-prepared, and we aliquot them and we keep them in the fridge, so that every time you have to do a procedure you don't have to start from scratch and start making them back up. So the trypsin is now added to the flask. So it's just enough to cover the surface of the flask, and this enzyme will start working now on the sticky proteins that will allow the cells to lift and detach from the flask. This can be left either for 3 or 4 minutes in the cabinet here, or if you want to speed the process up, it can go back into the incubator. So as you can see, having added trypsin, the digestion solution which detaches the cells, I can see now sheets of the cells detaching from the bottom of the flask. We're now going to add some culture media to this, and we're going to actually spin these cells down now in the centrifuge to be able to get a cell pellet to use to seed onto our scaffold. So this is now going to go back into the cabinet to be spun down. So the sterile culture media is now going back into the flask to help detach any remaining cells that are still at the bottom of the flask. And you wash the flask several times with the culture media just to make absolutely sure that you've removed all the cells that were originally attached. These will now go into a container, a universal tube, so that they can be spun down in a centrifuge so that we get a cell pellet of all the cells that we had in the original flask. So these will now be spun. So as you can see, having centrifuged this, we've got a lovely pellet, the white little pellet here, of the cells that we detached from the flask, and these are the cells that we're now going to reconstitute, and we're going to seed onto our prototype larynx. So we're going to go back into the cabinet now to reconstitute the cells. So just making sure that the pellet is nice and intact, we just pour the media, because the cells are stuck down in a very tight pellet at the bottom of the universal tube. Okay, so now we're going to reconstitute that in culture medium. Just give it a little flick to unstick the pellet. So the culture medium is added back into the universal tube, and the cells are dispersed by flicking it up 2 or 3 times with the pipette to make sure that we get the clump of cells is now dispersing. Having spun the cells down and got a pellet, we have then reconstituted the cells into this solution. So the cells are now in solution, and the number of cells that we add are dependent on the surface area, or how big our sample is. And because here we have our printed scaffold, that will be the scaffold on which we will seed these cells, and obviously we have quite a large volume here to cover the scaffold, I've reconstituted the cells in a higher volume of the media. So now we're going to add the cell solution to our scaffold. So this has been sterilised, so we've now put it back into the culture dish. We will add our solutions of cells. Make sure that the cells are well dispersed, because otherwise you'll end up having clumps of cells. And we're going to add these cells in a suspension. ensuring that the scaffold is completely covered. This is now ready to go back into the incubator, where it will be incubated for as long as it takes to ensure that we've got complete cell coverage on the scaffold. But what we will be doing is we'll be monitoring it on a daily basis to ensure that we don't get any infection and to ensure that we are actually getting cells onto the actual scaffold itself. Of course, we've previously tested this material so that we know that it's biocompatible, we know that cells attach to it, and we know that it doesn't cause any detrimental effect on the cells, and the cells do not die on the surface of this material. So we're now going to put this back in the incubator where we have controlled environment of temperature and gaseous exchange. And every 2 or 3 days we will be changing the media that the scaffold is in to ensure that we remove any toxins or any toxic reagent, and we replace it with new culture medium, because the culture medium contains all the nutrients for the cells to grow. So obviously as the cells are growing, they're depleting this media of all the nutrients, and we have to keep replacing that.